Hello, 8th grade math students. Welcome to my math videos. You haven't had as big of a taste of this so far this year as my 8th graders did last year, but boy, are you in for a treat. Don't worry, I'm just kidding. All right, this is the Unit 3 first practice problems. This was assigned on December 1st for Mrs. Trompke, and I'm going to go over each problem with you. You will get the answers if you watch this whole video. I will be honest with you, but I'm hoping that you're actually listening to my words and trying to learn something, and that by walking you through the problems, you will be prepared for assessments, quizzes, etc. All right. So problem 1, and I know you guys had a lesson from Mrs. Trompke on this between today or yesterday, so you're not totally clueless. You should know a little bit what I'm talking about as long as you're logging into your live class meets, which, just a gentle public service announcement reminder from me, it is a requirement of the next 2 weeks of distance learning. All right, problem 1, Priya. Priya jogs at a constant speed. The relationship between her distance and time is shown on the graph. We have time here, we have distance here, this is X, this is Y. Diego bikes at a constant speed twice as fast as Priya. Now remember, she's running, he's biking, so let's not judge either one of them. Sketch a graph showing the relationship between Diego's distance and time. So we just have to double this. That's really all there is to it. I'm going to go put some lines on. Okay, so look at. I'm looking for pretty points. Here's a pretty point. Here's a pretty point. Pretty point. Pretty point. Pretty point. So if at 0.2 hours, this is Priya, remember, Priya is the original line, went 5, 7. That means that our friend Diego at the same time had to go 2. Okay, that means at 4, Priya went 2, Diego would have gone 4. At 0.6, Priya went 3, so we need Diego to be at 6. And at 0.8, Priya went 4, so we need Diego to be at 8, way up here. So that's our new line. I just picked the points where I could tell they were neat. I call them pretty points, but really that just means they fall directly in the middle of the 4 lines. And I just doubled it because he's going twice as fast as her. And as you can see, that line is a lot more steep. It has a higher slope because he's faster. So it definitely makes sense. Okay, number 2. A U-Pick blueberry farm offers 6 pounds of blueberries for $16.50. Sketch a graph of the relationship between cost and pounds of blueberries. So, I'm going to start by making a little T-chart. So these are pretty big amounts of blueberries. I know I've never bought this many blueberries, but, you know, what do I know? And I'm going to do 6, 12, 18, 24, and 30. Because they told us that 6 is $16.50, right? And then I just have to add $16.50 each time. So $16.50 plus $16.50 is 33. And then another $16.50 would be $49.50. And then it would be 66. And then it would be 82.50. So this is just like $16.50 plus $16.50 plus $16.50 plus, you know what I mean? Because over here I used the ratio they gave us 6, so plus 6 plus 6 plus 6. That's how I got that chart. Anyway, in case you wanted to know. I'm just going to take these numbers now that I graphed, or that I wrote, and I'm going to attempt to graph them. I'm going to go to 30 and 82.50 first. 30's here. It's going to be about, you're going to be estimating, guys. This is not perfect. That's going to be about where that is. And I'm going to do my best to get all these points. So 6 and 16.50 is like here. 12 and 33 is like here. 18 and then almost 50, so that's like here. And then 24 and 66 is like about there. So then I have my graph, and I can put my little line in. And that's about what the graph would look like. If we were going to graph the relationship between the cost of blueberries and the amount of pounds that you purchase. All right, number 3. A line contains the points -4 and 1 and 4, 6. Decide whether or not each of these points is also on the line by checking off the boxes. So the first thing I have to do is figure out the slope of the line. You did this, x1, y1, x2, y2. And now I do y2, which is 6, minus y1, which is 1, over x2, which is 4, minus x1, which is -4. So that's the same as 4 plus 4, remember? 6 minus 1 is 5. 4 plus 4 is 8. So my slope is 5/8. Now I'm going to take one of the original points, and I'll tell you right now, I'm using this one because there's no negatives, and I'm going to test it to see if I get 5/8 again with each of these new numbers, okay? So I'm leaving that as my x2, y2, and let's do it out. So y2, 6 minus 3.5, or 4 minus 0. 6 minus 3.5 is 2.5. 4 minus 0 is 4. That is 5/8. Because 2.5 divided by 0.5 would be 5, and 4 divided by 0.5 would be 8. So that one is a yes. All right, I'm keeping this. I've got my 6 minus and my 4 minus. That stays the same. 11 and 12. 6 minus 11 is 5, -5. 4 minus 12 is -8. -5 over -8 reduces to 5/8 because they're both negative. So this one also is. I'm going to squeeze another one in here. Let me change the color so we can see it better. This is 6 minus 50 and 4 minus 80. Remember, I'm just getting these from up here. 6 minus 50 is -44, and 4 minus 80 is -76. Okay, yes, those will become both positive, 44 over 76. What can I divide these by? Let's see, I can divide it by 2, right? To reduce them. And then I would get 22 over, what's 76 divided by 2? 38. I could divide by 2 again. And I would get 11 over 19. That's as far as I can go. So this one here, no good, no bueno, it will not work. Last one, -1 and 2.875. I got to make myself some space here. So now I've got 6 minus 2.875 all over 4 minus a -1. So that becomes 4 plus 1, which is 5. 6 minus 2.875 is 3.125. So 3.125 divided by 5. I'm going to be totally honest with you. Don't know that off the top of my head. Breaking out my calculator, 3.125 divided by 5 equals 0.625. So now I have to decide, is that the same as 5/8? And in order to determine that, I'm going to do 5 divided by 8 on my calculator. And guess what? I did get 0.625, which means that this third one here is also an option. So the only one that doesn't work in this problem is that 80/50 number. All right, finally, last problem. We have to find an equation relating x and y. So Miss Tromke went over this in class a little bit, and honestly, she taught me how she wants this done by her going over it. It's a little weird. We might not do this totally right, but we're going to do our best. So we're going to call this x1 and this y1 and this x2 and that y2. And then the m equals slope, and it's negative 4 minus y over 2 minus x. Because they gave us unknowns for the other point. So that's as far as we can get with an equation. We don't know what the answer is. I mean, I can tell you from looking at this that the slope is probably 1, 2, 3, 4, 1, 1, 2, 3, 1, 2, 3. It's probably 3/4. I just did that by counting. But this is what she's going to be looking for in terms of having an equation. And again, it's a little funny. This type of equation doesn't make a lot of sense to me, but you're going to learn how to do equations regarding the lines a lot more closely going forward. And those equations do make sense. All right, guys, I hope you enjoyed listening to me ramble about math. In case you couldn't tell, I really love math. Doesn't bother me. I really enjoy it. Anyway, hope you guys are doing great. Keep up with distance learning. Remember, you only have 3 classes a day right now, so everybody should be able to keep up, and we are here for you if you need us. Have a great day. Bye.